Hello, hello brothers and sisters, welcome back to my channel. Today I'm gonna show you how to calculate land surface temperature using MODIS data with the help of Google Earth Engine API. Let's get started. First and foremost, we need to have area of interest to compute land surface temperature or any other project. So any shapefile or administrative unit is crucial to perform a certain activity in Google Earth Engine. So in my case, I would like to use the administrative boundary of Ethiopia to calculate land surface temperature. So as far as the shapefile is concerned, you can upload from your asset, or you can upload from your device to asset, and you can import from your asset to script window. So in my case, I have a shapefile. The shapefile is represented as ETH. This is a variable name. So this is the shapefile or region of interest. The second step that we have going to do is step one. In step one, we need to visualize the shapefile. So visualize shapefile. To visualize the shapefile, we can use a function of map r layer. The variable name is Ethiopia. That means this variable name or this administrative unit. Then the zoom level is 6. So map dot center object, the variable name is Ethiopia with a zoom level of 6. So you can execute and have a look the shapefile that is uploaded to the base map. In my case, this is the administrative unit of Ethiopia, which is uploaded on the base map with a zoom level of 6. Next step that we are going to do is selecting or importing land surface temperature image collection. This is step 2. Step 2. So as far as step 2 is concerned, let me assign a variable. The variable name is MODIS. MODIS is a satellite image that helps us to compute land surface temperature of Ethiopia. To gain the image collection, you can go to the search window here, the search bar, and write LST, land surface temperature. We have different ample sources of land surface temperature at a global scale. So here we have the Terra land surface temperature emissivity daily global with a spatial resolution of 1 kilometer, and there is also 80 days global coverage with 1 kilometer spatial resolution. For the sake of this exercise, I will give spatial emphasis to land surface temperature emissivity daily global scale at spatial resolution of 1 kilometer. So click here and let us explore the dataset. As far as the dataset is concerned, there is a general description about Terra land surface temperature and emissivity here. There is kilometer grids, and there is also bands. As far as the band is concerned, this is very crucial. Land surface temperature daily with 1 kilometer spatial resolution, and the minimum value and the maximum value is written here. The other important point that is considered here is the unit of measurement of land surface temperature is degree Kelvin. So to convert degree Kelvin to degree centigrade, we need to subtract 273.15, and we will get degree centigrade values. Before that, we need to convert a scale factor of 0.02. This is a constant number we will use in the upcoming steps. So the step 2 is having the data set of the Terra land surface temperature, and we need to copy this link. Collection snipped, you can copy this, or you can select and copy this link. then close and get it back to script editor. So you can simply replace this by paste. So this is a global scale land surface temperature data, and we need to rearrange, we need to filter out based on our study area and based on our time limit. So dot filter dates, we need to filter dates. In my case, I would like to calculate the land surface temperature from January 1, 2023 up to that of December 31, 12, 2023. Today is 28th of November. So I would like to give range from this to this, and I need to select LST day 1 kilometer. This is a data set. So you can simply filter out and you can run. You can print and have a look the MODIS data. Let me show you print MODIS. Because I have declared MODIS and I have filtered out in terms of date, and let us have a look the printed value. Here we have 324 elements of MODIS data between the January 1 to December 31st. Therefore, you can explore. So here we have the selected MODIS data on a daily basis. So each day have its own data set here. So the next step is converting from degree Kelvin to degree centigrade. Converting, this is step 3. Step 3, let's convert degree Kelvin as I have mentioned earlier. Here, this is, sorry. This is degree Kelvin, and we need to convert into degree centigrade, and our final output of land surface temperature of the national scale of Ethiopia will be in terms of degree centigrade. So to convert from degree Kelvin to degree centigrade, we need to use a formula degree Kelvin minus 273.15. So the first step is assign a variable. The variable name is MODIS degree centigrade. So the input parameter of the data set is MODIS, and MODIS map the function of image, return image, and we need to multiply by scale factor. The scale factor is 0.02. That is listed, or that is depicted on band here. This is a conversion rate or a scale factor, and we need to multiply by 0.02, and we need to subtract from degree Kelvin to a constant number of 273.15, and finally we make it system start time. So you can simply run, and we can have a look this MODIS degree centigrade. You can print and have a look at the result. So you can print model MODIS data with degree centigrade, and we have 324 satellite images, and this indicates that we have 324 days of land surface temperature on daily basis, because I have used the daily basis 1 kilometer spatial resolution of land surface temperature, and we have 364 days per year, but now today the day is the 28th of November, so we have a remaining days, and up to today we have 324 land surface temperature values here. So the next step is step 4, chart of land surface temperature with a temporal analysis, since it is highly correlated with a time series data. It is listed on a daily basis. So we need to create a chart to convert or to generate a chart. What I am going to do is assign a variable uh, called TSC. You can give your own name, and here is a function UI chart image series. The image collection is the output data, or the converted in terms of degree centigrade from degree Kelvin. Here, MODIS degree Celsius. Then the region is Ethiopia, ETH, or the administrative boundary, and we need a reducer of mean, and the scale factor is 1000, because 1 kilometer is 1000 meter. So X property is system start, and set option. The title is land surface temperature, or LST temporal analysis. V-axis is title with land surface temperature in terms of degree centigrade, and finally we print the variable. After having this, we have printed here the chart. Simply, this is land surface temperature chart. If you are interested to see or to download, you can go to the right side and click here. So this is the land surface temperature temporal analysis on daily basis from January 1st to that of November 28th. So here there is a dynamic change of land surface temperature on the basis of months. So you can simply download CSV file of each day. Let me have a look. Look at here. I have, if you remember, the filtering date is from January 1 to that of December 31st. So the land surface temperature of January 1, 2023 was 29.236 degrees centigrade, and it goes to the end up to 20 November 2023, the land surface temperature was 26.739. So on each daily basis, there is the value of land surface temperature of a certain area in a given location. So you can also download the figure, and you can incorporate within your document. Let's get back to the final one. Final one is having final map. So image visualization is a final step. This step is step 5. As far as step 5 is concerned, it is related to image visualization. The variable name is mean degree centigrade. So the input variable that we have done before is MODIS degree centigrade. To compute a mean, we use a function of mean, and we need to clip in terms of administrative boundary of Ethiopia, and finally add the result. So let's have a look at the final view of land surface temperature of Ethiopia at a national scale. So we do have a layer of land surface temperature mean. So this is simply land surface temperature of Ethiopia. The maximum land surface temperature is found in the peripheral lowlands of Ethiopia, particularly in the Afar regional state, in Somali regional state, and north western lowlands of Ethiopia. So here we have the Borana Elkare lowland, and highlands of Ethiopia is a relatively low land surface temperature, is a manifestation of an area. So this is all about today's video. If you have any question, let me know. Don't hesitate to subscribe my YouTube channel, and you can easily compute land surface temperature with the help of this script, and I'll put this script on the description box. Have a nice day.